10.3.5, the reflection property. So in example 7, we're asked to compare the graphs of f of x equals 3 times 2 to the x and g of x equals negative 3 times 2 to the x. Okay, so again, we should recognize that both of these are exponential. In this case, a is 3 and our base multiplier is 2. And this one is also an exponential function where a is negative 3 and our base multiplier is 2. So if we put in some values, and again I'm going to put parentheses around our x before we substitute for the variable, especially important when we're plugging in negative numbers and fractional exponents. Okay, so if here we're going to do 3 times 2 to the negative 2, so 2 to the negative 2, we get 1 over 2 squared, which is a fourth, times 3 is 3/4. 2 to the negative 1 is 1 over 2 to the positive 1, so we get a half, times 3 is 3/2. And if we plug in a 0, 2 to the 0 is 1, times 3 is 3. 2 to the first is 2, times 3 gives us 6. And 2 to the second power is 2 times 2, which is 4, times 3 is 12. Okay, so again, our base here was 2, which tells us here as we increase x by 1, our outputs here keep multiplying by 2. And our a being 3 gives us the output when input is 0. Now, on g of x, we've got this 3 times 2 to the x is still in here, but now we've got a negative 3 times 2 to the x. We're basically going to take each of our answers here and multiply. We're going to have a negative. So if we think about plugging in negative 2 here, 2 to the negative 2 is 1 over 2 to the positive 2, which was a fourth. But now when we multiply that by negative 3, we're going to get negative 3/4. Okay, and similarly in here we're going to get negative 3/2, negative 3, negative 6, and negative 12. So again, our base here was 2, so again we can see as we keep adding 1 to our x's, our output here keeps multiplying by 2, and our output when input is 0 here, our value of a was negative 3, where over here it was 3. So we're asked to compare the graphs. So let's first graph f of x. So our y-intercept here at 3, we have a point at 1, 6, another one at 2, 12, a little off screen. And let's see, at negative 1 we had 1.5, and at negative 2 we had 3/4, and so on. Kind of approaches the axis here and gets this bend. Okay, so there's our graph of f of x equals, what did we have, 3 times 2 to the x. Okay. But now if we graph our other function, okay, so at 0 we had a point down here at negative 3, and at 1 we had a point down here at negative 6, and at 2 we had a point down here at negative 12, negative 1 we had negative 3/2, and so on. And so we get a graph that looks like this. So this is our g of x, which was negative 3 times 2 to the x. Okay, so we're asked to compare the graphs of these two functions. So we can see it should look like we can fold over and we have mirror images top to bottom over the x-axis. So we should be able to see that our graphs look like they are mirror reflections over our x-axis. So these two graphs are mirror reflections over the x-axis. Okay, well, this is called the reflection property. So the graphs of f of x equals negative a times b to the x and g of x equals a times b to the x are reflections of each other across the x-axis, which is exactly what we saw when we graphed those two graphs. So example 8 asks us to use the graph of the given exponential function to answer the following. Okay, so the first one asks us to write an equation corresponding to the given graph. Okay, so in this case, since they told us it was an exponential function, that equation is going to be of the form f of x equals a times b to the x. So our job is to find the value of a and b given by this graph. Okay, so let's look at some of the input-output pairs. So we've got 0 and 3, and we've got the ordered pair 1 and 6. So here we can see that when we add 1, increase x by 1. Now, to describe the relationship from 3 to 6, we could say that we were adding 3, but we were told we have an exponential function. So that means we need to think about what we need to multiply by to get from one to the other instead of adding. Okay, so in this case, to get from 3 to 6, we're going to think about multiplying by 2. Okay, if they had told us this was a linear function, then we would have thought about this increase going from 3 to 6 as an add 3. Okay, but for exponential functions, we need to find that base multiplier. Okay, so here's our b. There's our base multiplier. And then we also need the output when the input is 0, and so that gives us our value of a. Okay, so as we write our equation now, we've got f of x equals 3 times 2 to the x. Alright, so now we're asked for f of 1. So for f of 1, we're going to replace x with 1. So we're going to get 3 times 2 to the first power. So 1 factor of 2 is just a 2, times 3 gives us 6. And f of 2, okay, we're going to substitute 2 for x, so we're going to get 3 times 2 to the second power. So now we have 2 factors of 2. So 2 times 2 is 4, times 3 gives us 12. Okay, and again, these give us an input-output pair. So for an input of 1, we had an output of 6, and we see that point on our graph here. Okay, this also gives us an input-output pair of 2 and 12. Okay, so on our graph, we could plot a point at 2, 12, would give us another point on the graph. All right, but now D, we want f of something is 3. So now we're after the input. Okay, here we were given the input. Okay, so inside the parentheses is where we have our input. And so here we have an output of 3. So we're being asked for what input gives us an output of 3. And if we go to our table, we can see that that happens at 0. Now, unlike our quadratic functions, so quadratic functions, we had some weird things happen sometimes. So if we had an output of 3, oops. So if we had an output of 3, we could possibly have, and many times we did have, 2 places, okay, where the graph would cross at that particular value. Okay, but these exponential curves, unlike the quadratics that made this curve and then bent around and came back up, okay, our exponential functions don't do that. So they have this kind of bend in there, but they're either always increasing or always decreasing. Okay, they never turn around on themselves. Okay, so we found one input that has this output, and that's all there'll be. Okay, there won't be another one. And then here, again, we want to know what input gives us an output of 12. Okay, so again, if we extend our table, if we add one more, and again, the base multiplier was 2, so 6 times 2 would give us 12. Okay, so an input of 2 would give us an output of 12. So now we're asked to graph the function g of x, where it's just the opposite of our f of x graph, and label at least 2 points on the graph. Okay, so this means our g of x is going to be negative, and then 3 times 2 to the x. This was our f of x. And now we've got our negative in front. Okay. And so if we come up and graph that, okay, instead of at 0, 3, okay, the outputs will change sign, so we'll have 0 and negative 3. For an input of 1, the output will change sign, and we'll have a point down here at 1, negative 6. And so we'll get this graph that looks like this, okay, where again, reflection over our x-axis here.